Hello everyone. So today we have the square root of s root of 90 minus square root of s root of 60 all equal to square root of s root of 40. So s is the unknown. So if we solve together, first let's say solution. Recall that the nth root of s is represented as 1 all over s raised to power n. So if we apply this here, the equation becomes 90 to the power of 1 over square root of x minus 60 to the power of 1 over square root of x all equal to 40 to the power of 1 square root of x. We're going to say let 1 over square root of x be equals to n, so that the equation becomes 90 to the power of n minus 60 to the power of n equals to 40 to the power of n. So here we're going to divide both sides by 40 to the power of n, so that it will become 19 to the power of n over 40 to the power of n minus 60 to the power of n all over 40 to the power of n equals to 40 to the power of n all over 40 to the power of n. Again, if you see a to the power of s over b to the power of s, it means a over b to the power of s. Now we can write as 90 over 40 all to the power of n minus 60 over 40 also to the power of n equals to 1. 40 to the power of n divided by 40 to the power of n will give us 1. So if you simplify this, here to give us 99 over 4 to the power of n minus 6 over 4 also to the power of n equals to 1. And we're going to write 9 as 3 to the power of 2 and 4 as 2 to the power of 2. 6 will be splitted into 2 multiplied 3, and also and 4 again as 2 times 2. So we can write 3 to the power of 2 over 2 to the power of 2 is raised to power n minus 2 times 3 over 2 times 2 raised to power n equals to 1. Again, from exponential law, we can write as 3 over 2 to the power of n to the power of 2 minus, here the common factors can cancel out to be left with 3 over 2 to the power of n minus 1 equals to 0. Here we can assume 3 over 2 to the power of n to be equals to m, so that m to the power of 2 minus m minus 1 equals to 0. But this is a quadratic equation, and we can solve this using x equals to minus b plus or minus square root of b squared minus 4ac all over 2a, where a is equals to 1, the coefficient of m squared, and b is equals to minus 1, the coefficient of m, and c is the constant, also minus 1. So here, if we bring in our values, m therefore becomes minus 1 plus or minus square root of minus 1 squared minus 4 times 1 times minus 1, that is c, all over 2 times 1. So if we simplify further, m therefore be minus times minus, that's 1, plus or minus Square root of minus 1 squared is 1. Minus 4 times 1 times minus 1, that's minus 4, all over 2. So m is equals to 1 plus or minus square root of 1 minus times minus is plus 4 over 2. So from here, m is equals to 1 plus or minus square root of 5 over 2. From here, we can derive two values of m, where m1 is equals to 1 plus square root of 5 over 2, and m2 is equal to 1 minus square root of 5 over 2. So from m2, the square root of 5 is greater than 1. So if we do this very one, it will end up giving us a negative number, so it is rejected. So the only valid value of m is m1. So to continue, we're going to say recall that m was represented as 3 over 2 to the power of n. So that 3 over 2 to the power of n will therefore be equals to m1, which is 1 plus square root of 5 over 2. So here we're going to take log of both sides as log 3 over 2 to the power of n is equal to log 1 plus square root of 5 over 2. So if we do this very one, this power will come down to become n log 3 over 2 equals to log 1 plus square root of 5 over 2. And again, we can divide both sides by the coefficient of n, which is log 3 over 2 over log 3 over 2, here over log 3 over 2. So here, log 3 over 2 can cancel out successfully to give us 1, and 1 times n will be n equals to log 1 plus square root of 5 over 2 all over log 3 all over 2. Also remember that we had n equals to 1 over root s. So if we break this in, it will therefore become n as 1 over root s equals to log 1 plus root 5 over 2 all over log 3 over 2. If you take the inverse of this, it becomes root s equal to log 3 over 2 all over log 1 plus root 5 over 2. So square root of s can be written also as log 3 minus log 2 all over log 1 plus square root of 5 minus log 2. So at this point, we're going to employ the use of calculator. Log 3 from the calculator is given as 0.4771, and log 2 is the same thing as 0.3010, and the square root of 5 from the calculator is 2.2361, so that 1 plus the square root of 5 will become 3.2361. And if you take the log of that, log 3.2361, we arrive at 0.5100. So if we bring this value into our equation, root of s will become 0.4771 for log 3 minus log 2 0.3010 all over here log 1 plus root 5 is given as 0.5100 0.5100 minus log 2 is 0.3010. So root s therefore becomes, if we subtract the numerator, we end up with 0.1761, and that of the denominator we have 0.209. Root s, if you do this one, is equal to 0.8426. So what we do next is to take the square of both sides, that is root s to the power of 2 and this to the power of 2, so that the square root can cancel the square, so that s will therefore be the square of 0.8426 is given as 0.70997, and s is approximately 0.71. This is the final value of s with the help of the calculator. Thank you for staying tuned to this end. Bye bye.